Okay, this is the third video on the semester exam review solutions. This one is going to be 21 to 31. I know that's a little farther, but it takes us to a nice stopping point. So two studies are run to compare, this is number 21, two studies are run to compare the experiences of low-income families receiving food stamps to those receiving cash subsidies. The first study interviews 50 families who have each been in each government program for at least 2 years, while the second randomly assigns. So here we're interviewing and here we're randomly assigning. Which of the following is a true statement? Both studies are observational studies. No, the first one is. The second one is an experiment. Again, both studies are observational studies. The first study is an observational study. The second one is an experiment. And that is correct. So number 21 is letter C. Okay, this one they're interviewing you, doing what you've already been doing or have already done. Here we're randomly assigning you treatment. Random assignment of treatments is associated with experiments. Okay, so that 21 is letter C. Moving on, number 22. Which of the following distinguishes an observational study from a randomized experiment? In an observational study, volunteers are always used, where in a randomized experiment, a random sample is always taken. That's not always the case. Matter of fact, most of the time in experiments, we have to have volunteers. Why? I can't force you to do something. So I have to have you volunteer to be part of it. In an observational study, a random sample is always taken from the population, whereas in a randomized experiment, volunteers are always used. Once again, not the best response here. It's not completely false, but not a very good response. In an observational study, treatments are not randomly assigned. That's true. Whereas in a randomized experiment, treatments are randomly assigned. That is the major distinction. So if you're looking for the major distinction, that's it right there. So 22 is letter C. In a recent poll of 1,500 randomly selected eligible voters, 35% said they did not vote in the last election. So 35% said, hey, I didn't vote. However, the actual vote count showed that 80% didn't. What types of bias is most likely to have occurred? Well, non-response bias is what happened on the election, but that's not to the poll. They responded to the poll. What really happened was they asked an uncomfortable question. As an American, it's our privilege to get to vote. So there's an expectation that you vote. And you feel kind of bad if you didn't. So, hey, 35% said, yeah, I didn't do it. But really, it was 80% because they didn't want to feel bad. So because it was a sensitive question and they weren't doing what they were supposed to, the answer here is D, response bias. It's kind of like this. How many times has someone asked you, hey, have you done all your homework? And the answer is yes, or almost, when you haven't even started. Again, it was a sensitive question. This is exactly the same type of question. Hey, did you vote? Oh yeah, I did. Because you didn't want to tell them, you didn't want to look like a bad person because you didn't vote. All right, number 24. A school principal wanted to investigate student opinion about the food served in the school cafeteria. The principal selected a random sample of 50 first-year students, 50 second-year students, 50 third year, and 50 fourth year. In other words, freshmen, sophomores, and juniors. Which of the following best describes this sampling? First off, we have groups. Oops, I just bumped that out of the way. First off, we have groups. And anytime you have groups, it's either stratified or cluster. But in this case, each group is different. We only have freshmen in one group, sophomores in one group, juniors in one group, and seniors in a group. And so basically, when I break you down into a group that doesn't, the individual group does not represent the population, because this one only has freshmen, it does not look like the population. Clusters have to look like the population. This is broken down by a common characteristic or a similar characteristic, which was grade level. And if it has broken into a similar characteristic or strata, it's known as a stratified sample. 25. A randomized block design will be used in an experiment to compare two lotions that protect people from getting sunburned. Which of the following should guide the formation of the blocks? Well, when you block, you need to block on the characteristic that you think will impact the study. And gender might, age might, or how easily some people burn, because some people burn substantially easier than others. So, participants in the same block should receive the same lotion. That's false. Within the block, we need to have both types of lotion. Participants should be randomly assigned to the blocks. That's false. We're breaking you on a common characteristic. I didn't get to randomly assign you to be a female. I didn't get to randomly assign you to be a male. Participants should be kept blind as to which block they are in. That's false. Pretty sure you know which one you are, male or female. Participants within each block should be as similar as possible. That's true. That's true for stratified. That's true for blocks with respect to how easily they get sunburned. Yeah, if we want people in the block, one block is like, hey, you know what? They're light-skinned redheads. They burn easily. We probably want them in a block separate from someone who's darker complected. Okay, darker complexion tends to burn less than those with red hair. Participants within each block should be as different as possible. That's false. They should be similar. Okay, participants should be similar. Stratified samples, you should be similar. The previous problems, they were similar because they were all freshmen in one group. All right, number 26. Which of the following is a true statement? If bias is present in a sampling procedure, it can be overcome by increasing the sample size. False. Bias cannot be fixed. There is no such thing as a bad sample. Well, if you have bias, then you have a bad sample, so that's false. Sampling techniques that use probability effectively eliminate bias. That's questionable. That's close. Let's see if we have a better answer. Convenient samples often lead to undercoverage bias. Bing, 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 we have a winner. That is very much the case. All right. This doesn't effectively eliminate bias. It helps minimize, it helps with it or can help eliminate it. But the way you eliminate bias is a good designed study. Design your study and execute your study well. However, if I take a convenient sample, I sample the people at the lunch table, then chances are that was convenient, that was easy to do, but I only represent one sample because they sit together because they're friends and like certain things. All right, finally, voluntary response bias. Voluntary responses samples often underrepresent people with strong opinions. That's false. They overrepresent. This should be overrepresent, not underrepresent. So D is our answer there. Number 27. One of the most bothersome side effects of antihistamines is drowsiness. In an example, 2 antihistamines are tested on 3 age classes, 12 to 19, 20 to 59, and 60 to 80. Once again, I broke them down into groups. Okay, in each class, the participants are randomly assigned. So this tells me I'm working with an experiment, and I broke them into groups. It's important. Which of the following best describes the design of the experiment? Okay, if I break them into groups, it's either going to be blocking, well, excuse me, it's either going to be stratified or cluster if it's an observational study, but this is an experiment. So if I break them into groups, we're blocking. And what do we block them on? Well, we block them based on, we put them into age groups. So in this case, we block based on age, which is letter A. 28. You wish to survey people who have brought in their cars for service during the past month. You decide to pick a random sample of gas stations in the city. And I know you all don't know this because this is no longer the case, but gas stations actually used to fix cars. And then survey all the customers from those stations who had had work done during the past month. This procedure is an example of which type of sampling. So what did they do? They went to groups. So went to groups, cluster, stratified. Now, and they surveyed all. I see all, that makes it a cluster. All right. In the design of the survey, which of the following best explains how to minimize response bias? Well, remember, response bias is either a sensitive question or a poorly worded question. Increase the sample size. Nope, that doesn't fix bias. Decrease the sample size. That makes everything in statistics work. Randomly select a sample. That's important, but we're talking specifically about response bias, so I'm not sure that there might not be a better answer. Increase the number of questions in the survey. That just doesn't do anything. That doesn't help with bias. Carefully word. Well, remember, response bias is either a sensitive question or a poorly worded question. So letter E, if I carefully word and field test it, then I get rid of the poorly worded ones. So I get rid of some of my response bias. A sales representative wished to survey her client base of 47 companies. Okay, so she has 47 companies for clients. She has business cards for all the same size for all the contacts in the company and drops them in a small box. She shakes them up and she randomly reaches in and picks in 5 cards for a sample. She could have picked any 5 cards. And she only had one hat, so to speak, because she only had one hat, and she could have picked any group of 5 cards. This makes it a simple random sample. Single hat, simple random sample. Number 31. A human resource department plans to survey 100 of the 3,000 employees in the firm. An alphabetical list of employees is available. A random number between 1 and 30 is picked. And the sample consists of the person that farther down the list with every 30th. Anytime I start off random, and then every 30th, this makes this a stratified sample. Every nth term, every 30th, whether it's 50th, 25th, 5th, 7th, etc. This makes this a stratified sample. This is the end of the 3rd video.